Okay, let's get started on the last unit, the very last unit. Seniors and juniors is the last unit we're going to do. Seniors, if you can get all this done early, I would really appreciate it. I will post as much as I can this week so that you guys can get started, because I don't want you to have to work late into this. The packet is, if you're picking up the packet tomorrow, all this is that I'm going to put online is in the packet. So we're going to start with notes on derivatives, introduction to derivatives. So you guys know derivatives are used a lot in physics and calculus. And so if you're going to take calculus or physics, especially in math-based physics, this is what you need to know. The first part's a little confusing, but once you get the hint of derivatives, they're super easy. So we know how to find a slope of a line. Slope of line, rise over run. Okay, that's because it's a line. It's really easy to find a slope. But what if we had to find a slope of a line that, the slope of a secant line between 2 points? And if you don't remember what the word secant means, secant is a line that goes through a circle or a curve. So this red line is called your secant. And like I said, this part's confusing, but you're just learning the definition. Let's say I had to find the slope of this secant, this line. Well, I do rise over run, but usually when we write functions, instead of x1 and y1, we put x and f of x. So we find the slope of this. So this and this mean the same thing. Right? If your y value subtracted, your x value subtracted. Okay, so not different, it just looks more complicated. It's the same exact format. Well, as we keep moving these points closer and closer, it's going to change our slope a little bit. And as we change these closer, we use something called delta, which I erased in the last delta, but delta means change in. So delta x is a very small positive number, so it's the change that we're doing. So basically we're trying to get these points closer and closer, closer, closer together to find the limit of it. That's what limits have to do with it. So this formula, and this formula mean the same thing. Okay, so this is really your y1 minus your y2, your x1 minus your x2. All we're doing is we're adding a change, a very small change. This is the formula to find a slope of a tangent line. So basically you understand secant is a line that goes through, tangent is a line that goes right on the outside. So as we move these points closer and closer together, they're basically going to make a line outside. And so what you want to know is the derivative and slope are synonyms. And as the secant line approaches a tangent line, so as these points get closer and closer, and it actually makes a line that's tangent, just touching the angle, this is our formula. Because what happens is the delta x, or the change in these numbers, are going to be smaller, so there's no change at all. But there can't be no change, because there has to be 2 points, but as we get closer to 0. So that's the formula. So you'll see some things that we saw last chapter. So derivative and the slope of a tangent line is also called the slope of a curve local linearity. So what it means is the line close. As you get, local means closer and closer together. So a derivative is a mathematical operation which results in a formula that provides the slope of a function, x1 and f of x. And so you'll see it written like this, or a lot of times they like to use h's instead. It means the same thing. And you're going to look at it, you're going to do stuff, and you're going to look at the limits. So you're going to find the equation, simplify it, and at the end plug in 0. So you do direct substitution. So notation for derivative is just like the notation for a inverse. Put a little prime there, then you know that it's a derivative. And the derivative of fx is also a function, so it has to be a function. So it's going to be something. So here's some pictures that you'll see on the notes that I attached. When we're trying to find the slope of a curve, you usually find the slope of a tangent line. And as we're going through a curve, there's lots of different tangents. There's one going up, there's one going down, another one going down, another one going up, and then one getting flatter. So basically we have to kind of come them all together. That's what the limit comes into. So basically you're going to hate this. and this is the long form of doing it. And as you do this, when you do the first worksheet, you have to use the long form. You're going to get mad at me. In the second one, you're going to use the short version, and you're going to love it. It's called the power rule. It's the easiest thing in math. But unfortunately, at the first part, you have to do the long one. So remember, this notation means you're going to plug x plus h for every x. So you're going to go 3 over 2 x plus h plus 1 minus the whole function. Make sure you put this in parentheses. Remember this. You hated this part. We've done this before. The only difference is the limit. So once we solve this, we're going to plug 0 in. So I'm going to distribute this. 3/2 x plus 3/2 h plus 1 minus, distribute that, over h. And so all I distributed is distribute the negatives. And now a lot of things usually cross cancel. So this and this makes 0, and this makes 0. And so what you have is 3/2 h over h. That cross cancels, and you get 3/2. No h to plug in. If there was an h here, you'd plug in 0. So the derivative, or the slope of this line, would be 3/2. Well, duh. That's y equals mx plus b. That is your slope. But because this isn't a curve, that's why the derivative is just the slope. It's a line. Of course, the slope of a line is 3/2. But what if it's not a line and it's some type of parabola? This is a parabola. It's upside down. Okay, so we're going to find the derivative. We're going to find the slope as the points get closer and closer together. So we're going to do the same thing. We're going to plug x plus h in. So it's 1 minus x plus h squared minus the function x squared, f of x over h. Again, you're going to have to do FOIL. I'll put it up here. X plus h times x plus h is x squared plus xh plus another xh plus h squared. So what you're going to get is 1 minus, make sure you put in parentheses, x squared plus 2xh plus h squared. So you're going to see two things different in parentheses. So you're going to see this part in parentheses is a minus, and this part I haven't distributed the negative. Now I'm going to distribute the negative to everything in here. So I have 1 minus x squared minus 2xh minus h squared. I'm going to distribute the negative here. Minus 1 plus x squared over h. Now when I gave you guys that at the beginning of distance learning, I gave you units 7 through 10 review. We had some of these on there. Can't remember how many. Okay, again, if you're not getting things cross-canceling, you're probably distributing the negative wrong. That cross-cancels, and that cross-cancels. So all we have left is negative 2xh minus h squared over h. Okay, so now I'm going to take out a GCF because they both have an h, and I'm going to cross-cancel. So what I have left now is the limit as, h approaches 0, not x. H approaches 0, and it really doesn't matter if you use delta x or h, because you might see delta x show up. It's the same thing, it's just a variable. And now all we have is this. So now what we're going to do is we're going to plug 0 into that equation, m for h, so negative 2x minus 0, and our answer is negative 2x. So basically, as the lines get approached closer and closer, we can find the slope of any point on that line by doing negative 2 times that point, times the x value. And you'll see later on what I'm talking about. Right now you're just kind of figuring out how to do it. But if the point, depending on where you're on the graph, you can plug in the value of x, like if you're plugging 5, then the slope would be negative 10 at 5, because it's very steep. I'll just kind of give you guys a little understanding. This is a upside down parabola, so maybe at 5 the slope is negative 10, or maybe at 1 the slope is only negative 2, and at negative 1 actually the slope is going up, it's at positive 2. Okay, so last example. Hard one, longest one, same thing. Gonna plug in x plus h in. So we are gonna do Everywhere there is an x, we're going to plug in x plus h. So negative x plus h squared minus 3 times x plus h plus 4 minus the original problem, put it in parentheses, all over h. Okay, again, order of operations, you have to do your exponents first, so we're going to FOIL that. And if you remember from the last question, that was x squared plus 2x h plus h squared, and you can use that on your homework. And so I'm just leave everything else here the way it was, and then I'll distribute the negative all at once. Oops, forgot that negative there. Okay, so now I'm going to distribute the negative to everything and add like terms. So to here, it's negative x squared minus 2xh minus h squared. Distribute there. Negative 3x minus 3h plus 4 doesn't have a distributed. Distribute here, positive x squared, positive 3x, and negative 4 all over h. Again, you should see a ton of things cross cancel. So I'm going to just circle it. That cross cancels, that cross cancels, and that cross cancels. I think that's the only thing. So we have left negative 2xh minus h squared minus 3h all over h. Now what you have left should all have a GCF if you can take it out. Like unless everything cross cancel and h just had one h. But if not, everything should have an h. So I'm going to take out a GCF of h. You have negative 2x minus h minus 3 over h, cross cancel, and now we're going to figure out the limit. So the limit as h approaches 0, all we're going to do is go plug in 0 into h, and that gives us negative 2x minus 3. So we can find the slope at any point on the parabola by taking the point and plugging in into it. Okay? So that's all you're going to do. If there's problems, you'll learn a shortcut after you do it, but you have to go through this process before you learn the shortcut. I will be posting the next notes as soon as I can. Good luck.